Hi, I'm Zin Linton. I studied computing at Edinburgh Napier University. My project title is Building a Prototype of the Autonomous Driverless System, Memo-like Transformer, and simultaneously evaluating using simulation and real-world environments. The core components of the project, there are two parts in this. The first part is to build a prototype of a very affordable quadrupedal robot. The basic things that it should be able to do is walk and drive like a car. The other part of the project is where I built a simulator to actually test your robot. That I believe is the greatest challenge that I faced during the designing process, the physical side of things, because the first design actually didn't make it through. The robot was a little bit longer, but the weights on there is quite heavy that the servos couldn't take it. And during the process I also developed mathematically a solution to overcome steering without actually turning the axles. So it's more like a tank basically, where it will slow down the motors on one side to kind of turn in the most efficient manner. So it can currently do that. There's a lot to be improved upon. Currently it doesn't have a camera, but I have proposed a camera module and tested it. Right now it can be controlled by a human controller or a pre-planned path, but in the future, very near future, it will be fully autonomous. I would really like to do research in the future, and I think this platform can help me achieve that, because I want to go into the either research about autonomous vehicles, and I think like demonstrating what I can do with this project could be a good indicator about what I can do in the future.
My name is Clara Kramer and I studied computing science at the University of Aberdeen. My project title is Interactive Visual Data Engineering. Data engineering is maybe not something that is well known yet in the computing community, but it is extremely important in all modern projects. It's basically a pre-processing step before the machine learning model is applied, and that then ensures that the machine learning model is trained on representative and the high quality data. I chose this because I worked previously as a data analyst in a consulting firm. I spent most of my time just cleaning data, and I spent so much time on it that I had barely any time to do the analyses themselves. So I chose to address this and hopefully make the world a little bit better. So my approach is completely unique in that it combines both human knowledge and machine capabilities. So the human makes the domain decisions, and the machine does the computationally heavy tasks. It's an interaction. Computer does something, human does something, computer does something, human does something. And then hopefully in the end we get optimal data. Building the program was a challenge for me in this project because I had to teach myself a completely new framework within like the first week of my project. And what makes my project so unique is that it uses visualizations as an interface for the computer and the human to talk to each other. Anyone should be able to use this, because in data science there's a huge accessibility issue. A lot of people have a lot of data and a lot of ideas about it, but they can't do anything because they have no idea of how to clean the data. I learned many things, I'd say, especially about data quality and how other research projects have maybe approached data quality in the past. So it's been really great to see how different people, different research groups have addressed this problem and kind of come up with an approach that combines the best of all of these approaches. I'm so glad to see that my work is important and that it's actually being used and maybe being continued further so that we can fix all the little issues that I had in my code and the next person can hopefully make it better.
My name's Verity Powell. I studied computer science at the University of St Andrews, and my project title was Video Analytics for Rugby Skills Training. What I wanted to do was, having been in women's rugby and seen the underfunding, I wanted to look at a way that community level athletes could get access to technology in helping them make their skills better, helping them track their game progress, because we just had barely access to coaching. So was there a way to add technology in to help that? Because one of the big things that kind of came across in the research was that lots of the software is using really specialist cameras with really high frame rates. The idea was to build an app that could use your phone camera. So the whole idea was keeping it really simple, 30 FPS, and your phone and a tripod was the limit of what you'd need to use it. I looked a lot into American football and also into golf in that kind of self-recording player aspect. So I looked into a lot of apps and a lot of tracking technologies and how they were working and how people were using them. I think I had 11 participants. They were all like rugby players, members of my club. I think I took about a couple of videos of each of them kicking the ball just from different like measured distances. And then I split them all into frames, hand labeled every single image of like, I think it must have been over 2,000 images. So then a lot of it became about like being able to take the ball path and extrapolate from the ball path what a person's body was doing. So like if you kick to the left of the post and you're right-footed, you've swung your hip too far right. It was really interesting when I finally like had designed the software to be like really simple, really thought through everything, and actually gave it to my friends and they were like able to like click it and use it. I was like, that's success.
My name is Naomi Silva. I studied applied computing at the University of Dundee, and my project is the creation of Novastock, a handheld gaming console. The Novastock is a DIY handheld gaming console aimed at tinkerers, people who like to build things. It's completely upgradable from the ground up. Anyone can do it at home with easily purchasable commodity bits. It was a very laborious process, learning 4 completely different industries: CAD software, soldering, physical computing, 3D printing. I think I spread myself thin a little bit too much. I got it done, which is kind of a miracle, but the limitations are based on hardware, not the software. And as the tech inside of it grows, people will be able to buy the updated hardware, pull their old one out, put the new one in, and then it'll suddenly be able to play Xbox 360 games, maybe Xbox One games. It first started with the main computer. It's the Raspberry Pi 5. I wanted to take it handheld. What handles the button inputs and passes them to readable inputs to the Raspberry Pi 5 is a Raspberry Pi Pico. Tiny little microcontroller, about £4, that you solder all of the button inputs to. Have a big long script that goes, when this button is pressed, send this button through to the Raspberry Pi 5, and it all works completely seamlessly. To print it, I did little prototypes, physical prototypes, then did a lot of drawings, and then worked that up to CAD software. Everything has to be millimeter perfect, especially with additive manufacturing like a 3D printer. So I spent about 3 weeks watching hundreds of YouTube tutorials on how to get it done, weeks modeling, and then went through about 4 or 5 prototypes with the engineering labs here at Dundee. Version 2, or the Novastock Mini, is going to use a slightly different Raspberry Pi computer, one a lot smaller, one a lot thinner, that'll allow me to cut the size down by well over half. In the future, there's so many things I would love to do, particularly physical computing. I want to sit and have conversations with my users of something I'm working and help them help make our product better.